Assalamu alaikum. As I have already told you some brief definition about power plant engineering. So I also written here some simple definitions of what is power plant engineering. So I will tell you only in a simple way what is plant engineering. It is actually a designing of a plant for the generation of a power, and for the generation of power maybe it is electrical energy which is almost used in the present age. And for designing the power plant, it needs mechanical as well as electrical as well as civil skills. So I have written here the assembly of equipment that produces mechanical energy utilizing the available energy source and converting it to electrical energy is known as power plant engineering. There are some other definitions of it. You can also understand very easily from my notes. And I cannot make big videos because there are some problems in uploading these videos. So I will go briefly on all the topics. So after that, I have written here some classification of power plant engineering. That these are actually in your syllabus. There's a hydroelectric power plant, thermal. It's also called a steam power plant, gas turbine power plant, diesel engine power plant, nuclear power plant, solar power plant, wind turbine power plant, and the last the power generation from exhaust heat. So first six sections are in your syllabus, and the last two it will be our extra task if there will be some time. So we will discuss these things also, but these are based on modern technology. That the last sections I have written here. So first we'll complete our syllabus, then we'll go beyond after that. So let us move on the first unit of what is the first unit. It is a fuel and combustion. And fuel and combustion, you have to understand two things. First is cycles, and the second is fuels. And in cycles you have to understand what is Carnot cycle, जो आपने प्रीवियस सेमेस्टर में पढ़ा होगा, व्हाट इज कैरनॉट साइकिल. एंड यू हैव टू फाइंड इट्स प्रोसीजर, हाउ टू फाइंड इट्स एफिशिएंसी, जो भी ये भी आपने पढ़ा होगा. एंड रीहीटिंग साइकिल, reheating cycle will be also discussed in later units. So this time I have already mentioned here it. And we will discuss also Rankine cycle and the Joule cycle or Brayton cycle. So we will discuss first what is Carnot cycle. It is also called a reversible ideal cycle, and it is given by Nicholas Leroy Saudi Carnot. So it is also named on the basis of that scientist as Carnot cycle. So it is actually why it is called a ideal cycle and theoretical cycle, because it is not possible practically, because the four processes occurring in Carnot cycle, as you can see from the PV diagram, the four processes occurring in Carnot cycle are supposed to be reversible. So practically there is no process practically reversible. That is why we are called it ideal cycle. So there are four processes in Carnot cycle: isothermal expansion, adiabatic, reversible expansion, or it is also called asymptotic process. Fourth and then 3-4 is isothermal compression, and 4-1 is adiabatic compression. Also called adiabatic reversible compression, that is called asymptotic process. ये सब आपने पढ़ा है previous semester में, so I am just repeating here. So also TS diagram, you can see here from TS diagram that heat is input in two processes, that is isothermal processes. In isothermal expansion, heat is added, and during isothermal compression, heat is rejected. So based on these two processes, we have to calculate it is thermal efficiency. So let us first see process 1 to 2. It is isothermal process, and it is a constant temperature process. When it is constant temperature process, their heat then change in internal energy is 0. So using then first law of thermodynamics here, I have written everything here. First law of thermodynamics, then you can as you know, first law of thermodynamics, dq is equal to du plus dw. So when you put this value du is equal to 0 in first law of thermodynamics equation, so you will find that dq is equal to dw. So putting the values, as you know, the work done for the isothermal process is P1 V1 ln V2 by V1. So in place of W you can write here Q1, because Q1 is the heat. It is given to the system during process 1 to 2. Similarly, for process 3 to 4, it is isothermal compression process, and same thing happens here. That is, change in temperature is 0, so change in internal is also 0, because internal is a function of temperature. So in that case, in process 3 to 4, heat is rejected as Q2 and is designated as Q2. So when we put this value, so it is a isothermal compression. So if it is isothermal compression, that is work done on the system. So when we put then this work done will be negative. So when we put this value in first law of thermodynamics, that is dq is equal to u minus dw. I have put here negative sign because it is a compression work. So then dq is equal to minus dw. So यहाँ पे जो आएगा आपको Q2 is equal to minus P3V3 ln V4 by V3. So V4 is the is the final volume, and V3 is the initial volume. And to remove this negative sign, so if I change the limits here, if I write here P3V3 ln V3 by, if I shift the limits, यहाँ पे था P4 by V3, if I write here V3 by V4, then it will be negative sign will be out, then that negative sign will be cancelled with this negative sign, so it will become positive here. So because of this, that negative is positive, it will be P3V3 ln V3 by V4. So Q2 is equal to P3V3 ln R. So R is a compression ratio. So we can write, as you know, for ideal gas equation, PV is equal to MR, PV is equal to MR. So here is P3V3. So I write here MR T2, because T2 is the temperature for the process 3 to 4, and T1 is the temperature for process 1 to 2. So because the cycle is working between the temperatures T1 and T2, that is higher temperature and lower temperature. So this is second equation. So on this equation, on their basis, so other two processes are here, that is isentropic compression and expansion. They change their, since the decrease in internal energy during the process 2 to 3 will be equal to the increase in internal energy during process 4 to 1. So जो decrease हो जाएगी internal energy process 2 to 3 में, जो isentropic expansion process है, वो ही इतनी इंटरनल एनर्जी आपको गेन हो जाएगी किस प्रोसेस में, 4 to 1 में. So that will be equal, so these two internal energies will be balanced and they are cancelled here. So that is why we are not considering these two processes in calculating the efficiency. That is, increase internal energy during process 2 will be equal to internal energy during the process 4 to 1. And in 4 to 1 it is positive, and in 3 to 3 it is negative, so they are cancelled here. So that's why u2 to 3 is equal to u4 to 1. So the net work done will be equal to q1 minus q2. So putting the values of q1 and q2 here, so we get thermal efficiency is equal to net work done divided by heat supplied. So putting the values of net work done, that is q1 minus q2, and heat supplied, so finally you get thermal efficiency is equal to 1 minus T2 by T1, that is final temperature by initial temperature. And also you know that thermal efficiency is also equal to 1 minus Q2 by Q1, that is heat rejected divided by heat input. So these two equations, and it is also equal to 1 minus T2 by T1. So finally you can get T2 by T1 is equal to Q2 by Q1 is equal to T2 by T1. This is a very important equation, is as you know, it is used for defining the entropy and to calculate the value of entropy. So finally the heat is a function of temperature also. So this was all about Carnot cycle.